In this video, I want to do a little introduction to derivatives of inverse trigonometric functions. Yeah, so here they are. So now these look not so nice, but the truth of the matter is when we're differentiating these inverse trig functions, the work that goes into them is not too extensive, and the algebraic simplification is not too extensive. So the good news is if you know how to apply these derivative formulas, the rest is pretty simple work. So let's just go through them one by one real quick. The first one in the top left corner is the derivative of the inverse sine function, and that's equal to 1 over the square root of 1 minus x squared. And if you look at the inverse cosine function over on the top right, you'll notice that the inverse sine derivative and the inverse cosine derivative are exactly the same. The only difference is the sign sine out front. The inverse sine derivative is positive and the inverse cosine derivative is negative. And the same thing goes for the inverse tangent function and the inverse cotangent function. The inverse tangent function is a positive value and the inverse cotangent function is a negative value. And again, same thing goes for inverse secant and cosecant. One's a positive, one's a negative. Now, the one specific thing that I need to point out is when we're applying these derivative rules, the x value that is here will always be plugged in here. So in other words, if we have sine inverse of 2x, then we'll plug in 2x here, and 2x will be squared. Or if the argument of the inverse cosine is 17.5x, then that's what we'll plug in here, 17.5x squared. So whatever we see here, we'll always plug in there. Okay, one last thing. As we work through these examples, you'll see that when we're evaluating the derivatives of these inverse trigonometric functions, the one thing to keep in mind is chain rule, chain rule, chain rule, chain rule, chain rule, chain rule. Because in almost every situation, we're going to apply the chain rule to the derivatives of these functions. All right, that's really it. So now let's get to work looking at some examples.